All right, everybody with me on that? So you use the thin film. And so you have the 2, 1.33 T, and I already can't remember. Did I say constructive, I think?
Yes.
All right, so I want constructive. I have m plus a half lambda. Normally this would have been destructive interference, right, from the stuff we learned before?
Yeah.
But now it's constructive because why? There was a phase change. And a phase change means half a wavelength off. So it basically shifts it back into the same phase. So this is constructive interference. And that would be obvious from the table. All right, that should be clear from the table. You look at the one. But so at this point, if I give you lambda, there's a variety of number of m's you can choose depending on how I word it. So usually we'll say the thinnest, which is code for the smallest value of m. What's the smallest value of m that works for this? 0. Yes, Vanessa.
We need to go over that.
Okay,
Starting where?
so we know that there's one phase change, and now how do I interpret the chart? How do I know if it's
All right, so let's do the chart.
descriptive or?
So I have 0 or 2 and 1, and I have constructive, destructive, destructive, constructive. All right. So what happens is that if I want constructive interference with 0 or 2, I just have m lambda. If I have destructive with 1, 0, 2, I have m. Actually, I think I didn't do it this way before, did I? Because no, this is going to be confusing because of this.
No, you did.
Okay. All right. So, yeah, this is 20 equals 20. So what happens if I have 0, 2, then this is going to give me constructive because 0 and 2, the 2 cancels. 2 phase changes cancels. If I brought things together and one gets out by a half and it gets out by another half and back together again. Right? If I've got 2 waves, getting out by half means they're like this, but getting off by half again puts it back together. So these are the same thing. So integer number of wavelengths with no differences give me constructive. But if I do have a phase change, then now we're automatically off by a half, so that makes it destructive. If I have 0 or 2 and I'm off by a half, that's going to cause destructive interference, unless I also have a phase change which puts it back together. So in terms of waves, off by half cancels. Because if you look at the waves,
I still don't get it. Like, okay, so what wave am I looking at?
I'm going to draw.
Thinking about?
Look, I've got a wave that looks like this, right? I have another wave that's like this. Are they together or not? All right, so that means if I was here and I shifted it here, you can't tell that it got shifted. So if I shift by a half, that means I got it here. Because this is a wavelength, and so I shift by half a wavelength. Now that's clearly going to cancel that because they do exactly the opposite, so they completely wipe each other out. So if I'm off by just a half a wavelength, then that takes
How
this.
do I know that now?
You have to count the
Okay,
phase
we're
difference.
looking
The
at
phase
this.
changes.
And we know there's one.
So but you say I had one phase change,
Okay.
and I say now, oh, I have to ask you, find the places for destructive interference, find the places for constructive interference. I have to ask the question. And when I do, then you look which one of those you want and choose your equation.
Oh, so you're gonna ask either or? So
Well, I mean, so let's just make one up, all right? So I say, all right, I've got this situation, and I say, find the thinnest film for which blue light is canceled. All right, so I'm saying blue light is canceled. What's that code for in your head? Canceled means destructive, right? What's that? Oh, all right. So, but you got it, right? Is that?
Okay.
And so I said I have one phase change, and I want cancellation, so I use destructive.
What's the other word you would use for
Actually, for thin films, I wouldn't. So yes, I kind of give that away. If it's thin films, it doesn't. I could ask for what is the thinnest the thinnest film for which blue light is constructively interfered. Actually, I can ask that question. It just won't look blue, but I can ask the question.
But it kind of has a word in it already.
Well, yeah. I mean, that's the problem. Is if we have single things, we can say where's the bright spot. But the problem is when you're using white light, just because blue is constructively interfered doesn't wipe the other light out, so it's not going to look blue. So I would have to say constructive. And yes, constructive or destroyed or missing, those are code names for It's constructive and destructive. I mean, the main thing is, it sounds like you're trying to make it hard, and it really isn't.
Okay.
It's going to be obvious in the problem, and if it's not obvious, ask, and I will say, that's destructive.
Okay.
All right? I'm saying it's missing, I mean it's destroyed. Okay, all right?
Okay, so let's say that the end, the 1.33 was higher than the 150. Then you have two phase changes, right? So let's say that was somewhere in between those two numbers. Then you've got two phase changes.
Correct.
And then you do two. And then if you're trying to be constructive, you go to that.
Exactly.
And use that equation.
So you count the phase changes,
Okay.
however many you get, you come here and look which column, and then you choose either constructive or destructive based on the question that's asked.
Okay. All right.
Right? Based on the question that's asked.
Okay.
Like the homework mostly. In fact, the homework's a little more complicated than what I'm putting on the test.
How did you set it up again? You put 2 and then 1.33.
I had 1.33. So what do you mean, how
Can
did I
I see
have?
how you set it, once you put in the numbers?
Oh, you mean, what are the numbers I put in
Yeah.
over here? So first off, we've done
So
this.
it's 1 and it's destructive.
All right, so we do this, so I'm going to use this equation, and so I say 2, 1.33 times t, and I'm asking for the thinnest is equal to lambda, because the smallest it can be is m is 1. So the only thing I don't have is t, because I'll tell you it's blue, and I'll give you a wavelength of the blue, and I just solve for t mathematically.
So why was it 1.3?
It's called what? What's this whole process called? What's the name of this? Thin film interference. Where's the thin film? And what is it? That's where it happens, it's in the thin film. So if you use always the number of the thin film. Yes.
So m is the number of phase changes?
So what's that?
So m is the number.
Excuse me, guys, can you hold down the talking because I can't hear his question?
So m is the number of phase changes?
Yeah. M is the number of phase changes? No.
No.
M is the number of wavelengths. So what happens is, if I say the thinnest, we're going to choose M as 1, but if I say find the third, where 3 wavelengths occur or something, I'd have to word it a different way.
Didn't you say it was 0, the thinnest?
It's the thinnest when I use this equation. It's 1 when I use this one. All right, because if I put 0 in for M here, everything disappears. And that does occur on very, very thin soap bubbles, but it's not the question. This will cancel everything. So in this one, it's just like with the d sine theta equation. When we have this one, we choose M as 1. When we have this equation, we choose M as 0. Because choosing M as 0 doesn't wipe out the equation. Here it would, so I choose 1 as my lowest.
1 and 0.
Yeah, so 1's the lowest I can have here, 0's the lowest I can have here.
We should look at destructive.
What's that?
For this one, we're looking at destructive.
You could be constructive as well, depending on the number of phase changes.
No, I mean the one.
But yes, this one was destructive with 1 phase change.
It's because initially you had used constructive,
Yeah.
so that's why we were a little confused.
Did I say constructive at the
Yeah,
beginning?
initially.
Yeah.
Initially, and then when we went back to it, now you went to destructive, so we were just talking about it, and that's why there's 2.
Well, no, then, yeah, that's my fault.
But it's really
I got-
based off of how you ask the questions.
Yes, it's totally based on the question. Yeah,
So it's always, since it's the thinnest, it's always going to be either 1 or 0, right?
yes. But, and the way you pick it is if you've got plus a half, use 0. If you don't have plus a half, use 1. Because you can't, it's logic. If I put 0 in here, it wipes the problem out. It makes no sense.
Yeah.
All right, so you choose the thinnest that makes sense. Yeah, and I had forgotten. So you mean because I was saying let's choose blue to be constructive. Yeah, but typically on a problem like that, if I'm going to use that particular thing, almost never will I choose constructive because it doesn't make any sense. You don't see it. You see destructive. You see the color that's missing because it changes everything else. But you certainly can count. I mean, you can calculate for constructive interference. All right. So that's the thin film. Are we good?
Yeah.
Right. The only one remaining is the diffraction one. The interference diffraction problem, and I combined them into one problem. So this is because, as you did in lab, you saw that you really have both effects occurring simultaneously. All right. So if I think of the interference patterns, that's I'm going to just make my laptop better. So what I'm trying to do here, and there's so many dots on the board that I can't get rid of to make this confusing, is does this kind of look like some of the dots that you saw in the lab? Right, so we had this same thing. Do you all notice there's gap? Well, I didn't make it as big a gap as I wanted. All right, so there's a gap there. So the dots are evenly spaced, but where there should be a dot here and here, they're missing. Right, and we saw that in the lab, didn't we?
Yeah.
Why are those dots missing? Because the diffraction minimum wiped them out. Because the whole pattern is the combination of diffraction and interference simultaneously. So I know that the diffraction pattern wipes those out, and I know the others are the result of interference. All right? So let's first get some equations for interference. What, in terms of this kind of a problem that we've got set up, what is the equation that deals with, the two equations that deal with interference?
G sine.
D sine theta equals, all right, if I do m lambda, what have I found? Right. What's the first value of m? 1. So if I ask for the second bright spot, m is 2, correct? All right. What's the other equation? D sine theta, quantity m plus a half lambda. And this is dark. What's the first value of m? 0. So if I say the third dark spot, what is m? 2. Look at this. I'm here. When m is 0, first dark spot. When m is 1, second dark spot. When m is 2, third dark spot. Are you with me? It's a logic game. All right, it's a logic game. So the first 0 gives me, when m is 0 gives me the first dark spot. On the bright spots, m equals 0 takes me dead center and it gives me no information. So on this one, I do choose m as 1 as my first, but on this I choose m as 0 for my first. Are we good? What does D represent? So if I have two real slits, be really specific. What does D represent? From the middle to the middle. Is everybody good with that? It's not from the edge to the edge. It's from the middle to the middle. This becomes important when we're dealing with real slits. So it's from the middle to the middle. What does this distance represent? You knew where I was going. So this distance here is A, or the width of the slit. Everybody got that? A is how wide is it from side to side. D is how far from the center of this one to the center of that one. Both things happen. What's the other equation besides interference then? It's the diffraction. And the problem that we have with diffraction, guys, is there's only one equation because there is no equation for bright parts. All right? So we get A sine theta is equal to m lambda. It looks a lot like this, and it is confusing. Don't let it be. That's why we use A and not D. A is slit width, and it's for dark, not bright spots. So those two that look similar have entirely opposite behavior. All right. If I look at this, and I don't even tell you what D and A are, but I tell you, looking at this, I can see where the diffraction minimum occurs, and I can see where the interference maximum should have occurred and didn't. So where do these two things overlap? Where does diffraction and interference happen at the same point here? Right here. Is everybody with me? That's where they both occur at the same point?
Yeah.
What would the interference equation be for this point if the diffraction wasn't happening? Would this be a bright or a dark spot if interference is going on? It'd be a bright. So what would I say? M lambda. So I say D sine theta equals what m am I going to use? Look at my picture. I'm looking at bright spots. 0, right, red center. 1, 2, 3, 4. Everybody got that? Because the bright spot that's missing is the fourth one. That's the one where the diffraction pattern landed on and wiped out. All right? Then I asked, what's the diffraction equation that matches this picture? Is that the first diffraction minimum?
You gotta tell us though.
What's that?
Yeah.
Aren't you supposed to tell us whether it's first or second or third?
I'm kind of hearing you, but not really well.
Aren't you supposed to tell us?
I'm telling you, we can see, I can tell you in words, but I want you to see from a picture, you can see it without my using any words. Where in this picture can you see that the diffraction minimum actually occurs? At that same location, right? Right? So I say A sine theta is equal to what? Just lambda, because it's the first one, so n is 1. Do they happen at the same angle?
Yes.
Look at my picture. Are these happening at the same angle? It's a duh, right? I look here, interference is there, diffraction is there. It's the same angle. A trick that we use, and we've used it a lot, is simply make a ratio. Since those sine thetas are the same, because the angle's the same, that cancels. We're using the same wavelength, that cancels, and I find that d over a equals 4. What did it tell me? Go ahead.
Back to the, how is it just 1 again?
Oh, because it's the first one, right? So the first diffraction minimum occurred here. We didn't see one before that.
So if we were looking at the second blank space, then it's 2.
Yeah, so if we kept going, in fact, it would be here, then we'd see the second. But so, when I say d over a equals 4, what does that tell me? All right, so it says d is equal to 4a. Well, let's look at my picture here. This is a, that's d. It means if I went 1, 2, 3, 4, d is 4 slit widths. Okay, I heard it, wait.
What was that M? What was the M equal? Same question.
Why was M1 here?
Yeah.
Because if I look at my picture, let me push here. This is the. If I, let me sort of draw the diffraction pattern on top of this. So what's happening is that this is the first time the diffraction goes to 0. We don't see it wiping anything else out. So when the diffraction goes to 0, that's the first one. So that's raised times 1. But on the interference, it was the fourth one because I'd already had several interference patterns before that.
So, what I'm thinking, you want to give us one where we want to find a fraction. How would we know the M?
On just diffraction, you'd have to be told this the first or second. But for the picture, I mean, I would tell you if I do it in words, but on a picture, I want you to understand you can go both directions. If I have a picture, I can see it's the first one because it's the first dark spot. And I saw it, yeah.
How is the 4 again? Can you count it out?
All right, so centered. 1, 2, 3, 4th is that it's missing. So the fourth interference pattern is gone. So that's the one that matches the angle of the first diffraction. Never count the center one with bright spots. It's always the ones to the side. Yes, Dan.
And why do we use the right equation for interference?
Okay, because there would have been a bright spot there if interference could have made it, but the diffraction killed it. And how we know that is evenly spaced, it would have been there. And it's not. Remember, all the interference are always exactly spaced the same all the way across. If they're missing, diffraction's the villain. That's one of the things we were hoping for in the lab last week, one of the things we were supposed to look at, was that those bright spots from the interference pattern are very evenly spaced across the screen. Right? There were gaps, but anywhere that they were, that we could see them, they were evenly spaced. Yes, you know.
So how would you phrase this as a question?
All right, so let's just say this. I've got an interference pattern, I'm looking at it, and I know that the first diffraction minimum occurs on the second interference maximum. First off, what does that look like? So I'm saying the first minimum occurs on the second. So let's first do my interference. I'm not going to try to be as pretty as that. So this is my center, 1, 2, 3, 4, 1, 2, 3, 4. And I'm saying on the second interference maximum, I get a diffraction minimum. So it's basically going to do this, right? So what's the thing? D sine theta equals what? What am I going to put in? It's the second one. I'm going to put d sine theta equals 2 lambda. I'm going to put for the minimum of the diffraction, I'm going to put what? A sine theta equals lambda, because it's the first one. And so I'm going to get a factor of 2 instead of 4. All right, so instead of the picture, we gave you the words. Now what if I said that the first diffraction minimum matches the third interference minimum. The first diffraction minimum matches the third interference minimum. So again, make our picture. So, all right, so here's the center, and here's my interference 1, 2, 3. So that's the interference one, and I'm also claiming that that's my diffraction minimum. All right. So what do I write there? D sine theta is equal to. Be careful. It's a minimum. It's the third minimum. 2.5. And just land it. Does everybody understand why it's 2.5? Because when you're counting minimums, the first one counts as 0. So 0, 1, 2. 2 is a third. Because that equation never changes. I told you the diffraction minimum hit at the same place as that. Oh, it's not over lambda. I'm sorry. Yes, you're trying to correct my very stupidity. Whatever. All right. Thank you, Arturo. You're right. I was.
Okay, so you said that it's 2 because you count the 0, 1, 2.
And that's the third one.
Okay, is there a way that you can show us similar to decide how you count it out? Is there a way you can get that one? Like,
Yes.
visualize?
Yes. So it's 0, 1, 2. Remember, the first minimum is always 0. Look at my equation. When m is 0, I get 1/2. So the first minimum is 0,
Okay,
1, 2 is the third.
okay, okay, I see.
And that's what we use the 2.
Alright, thank you.
How did we get the half in the equation? Why did we use the
Why did we have the half?
interference? Yeah, why did we use the
Because I told you with an interference dark spot,
dark spot, okay.
right? And dark spots have to be here. By the way, I'm giving you these equations. You've got to know what to do with them, but I will give them to you. All right. So here's the deal. Like I say, I'll check my email over the weekend. All Monday morning, I get here at 7:30 or so until test time. I'll be around. You can ask questions that rise. I will answer emails if you have them. I'm going to go ahead and start on the H section because I want to make sure that we want to get to the point where their question is actually easy. It doesn't look easy at first blush, and it isn't at first blush, but it's pretty straightforward, but it's going to take you some time to set it up for them. So if you want to stay and listen to the H section and go through their hairy problem and laugh at them, you can do that. But otherwise, see, we've got to make them earn their H moniker they get for taking calculus. So if you're not going to stay, I appreciate you leave fairly silently. And I'm going to stay after that. So if you have questions you want to hang around, I'm going to stay until I make sure I answer people's questions before I go home for today.
Turn it off? Keep it active.
Don't turn it off. It won't get posted before the test, though. But still, let's leave it on because who knows, right? So here's the deal, guys. This is something called Fermat's principle. The interesting thing about it is that nobody knows why it works. So what our job is we're going to derive Snell's law from basic calculus and Fermat's principle, which basically says, what's the problem? No, what's the question? I probably have the best answer in the room, but it's physics. All right. So if we're going to use this principle, he basically says, out of all the possible paths you can take, the one that takes the least amount of time is the one that happens. Are you with me? Does that sound like a max-min problem? It absolutely is. So on the little handout I gave you this really ugly diagram, but I'm going to sort of walk you through it. So here's the thing. I've got a region of N1, I want to keep the same numbers, and a region of N2. And I'm going to have light start at some point and go to some other. I'll make it look like paper. All right. So here's the thing. I'm claiming the distance to the interface, the vertical distance to this interface is A, and the vertical distance to the interface for this one is B. So light is starting here at A, and it's going to go and get to here. So don't write this down. I could do this, I could do this, I could do this. Those are all possible paths I can take, correct? Right? So we're going to say, we need to set it up so that all those possible paths can be taken care of mathematically without actually having to draw them. So what I do is I simply draw a picture like this, and I say, That may not be what happens, but I will claim that if this distance is d if the horizontal distance from A to D is d, then this is x, and this is d minus x. Does that make sense?
Yes.
So that allows x to be a variable. So x can be any value, whatever it is, d minus x is the rest of it. Does that make sense so far? Everybody with me? All right. So then I'm going to call this length, whatever it is, I'm going to call it L1. And I'm going to call this length, whatever it is, L2. Just so I have an actual length or how long it travels. Okay. What is it I said I wanted to minimize?
How long?
How long, which is code for time. So I need to find an expression for how long it takes to travel there. Well, to do that, I remember that distance equals rate times time, right? So time is equal to the distance divided by the rate. That ring bells?
Yeah.
If I'm light and I'm in something with an index of refraction n1, how fast am I going? I can repeat that question. If I'm a beam of light and I normally go c in a vacuum, but I'm in something with an index of refraction of n1, what speed am I going?
C divided by 1.33.
C divided by n.1, I mean n sub 1. Does everybody agree to that? What's the definition of n? C over v. So v equals c over n. Right? I don't want this to be magic.
Yeah.
This is a definition of n, so if I just switch those places, I get that v is c over n. All right? How far is it going to travel to go from here to here? L1. So the how far is L1. How fast is it going? C over N1. Anybody have any questions about that? It's the length over the speed. Now when you divide by a fraction, that's the same thing as inverting and multiplying, so it's N1 L1 over C. You make my L's look less like C's. All right, are we good with that? Everybody okay? So I've got two pieces. I say the total time is equal to T1 plus T2, where T1 is this one and T2 is this one. Right? There's two pieces. They have different speeds, so I have to do them in two parts. So that says it's equal to N1 L1 over C plus N2 L2 over C for exactly the same reason.
Yeah.
Are we good?
Yeah.
All right. So at this point, then, this expresses the total time. All right. Now, here's the thing where it gets a little strange, actually. I just only realized there's a magic step that I do that I didn't realize I was doing until I went to prove it to you guys. L1 squared equals, if I look at my picture, a squared plus x squared, correct?
Yeah.
Does that make sense to everybody? This step isn't magical. It just resolved in my head. I'm relieved. I had a moment where my brain didn't catch up in my mouth and I wasn't sure what was going on. So this is just the Pythagorean theorem, right?
Yeah.
And I also have that L2 squared is equal to, help me out, b squared
D minus
Plus D minus.
d minus x squared. We good?
Yeah.
Everybody's good with that? Everybody know? Talk to me if you got a question. So I come here. I got this piece gives me a total time. What is the one variable in all this that I can change? There's one thing I can change, and if I change it, everything else changes to accommodate it, but it's the one thing that I can decide. Out of all the possible paths, what's the thing that changes? L's going to change only in response to changing something else. If I pick where it crosses, that's what changes everything else. So x is what changes. Is everybody saying x is my variable? Everything else is fixed after I choose x. All right, so, yes. So, once I pick x, that determines the lengths of the L1 and L2. Right? So if I pick a different x, I get new L1, but they're functions. X is the thing I can change that changes everything else. Therefore, if I want to minimize time, what is it with respect to? What thing can I change that changes the time? It's x. And I know in calculus you never saw stuff like this, but what I'm saying is, I want the derivative of the time with respect to x to equal 0. What is that setting up? If I make the derivative equal to 0, what am I setting up in the calculus problem?
Minimum, maximum.
Maximum problem, right? When you take the derivative and set the derivative equal to 0, you're either going to have a maximum or a minimum. And that's what we're looking for. We want to find the shortest time. So I said, cool, I can do that. Here's my t. I take the derivative of this with respect to time. But before I do that, I say, is n1 a constant? Yes. Is c a constant? Yes. So L1 and L2 are my only variables. So when I say this then, dt dx equals 0, I'm really saying that n1 over c dl1 dt plus n2 over c dl2 dt, dx equals 0. Because I'm taking the derivative with respect to x. Right? So I just take the derivative of each term with respect to x. That's all I've done. I don't know what this is, but I have everything I can find. These lead me to something called implicit differentiation. Does that ring any bells in your empty heads?
Oh, yeah.
What you do is you implicitly differentiate both sides. Well, we're going to differentiate both sides with respect to x. Let's just say we're going to do it that way. So that'll save you a step. So we'll just say, I'm going to differentiate this with respect to x. It's time to call home. All right. So, guys, when I differentiate something to the squared with respect to a variable that isn't the variable that's there, chain rule, what do? Hey, no, it's so easy. When you take the derivative of something to the squared, what happens? The 2 comes down, and you get L1, but L1 could be a function of x, so you multiply by the derivative of it with respect to x. It's just the chain rule. Right? The 2 comes down, making it 2L1, and then you take the derivative of the thing in the middle, which is the L1 with respect to x. Now, take the derivative on this side. A is a constant. What's the derivative of a constant? Bye-bye. Derivative of a constant is always 0. Yes, the derivative is 2. Yeah, all right. What's the derivative of x squared with respect to x? 2x. All right, notice then, I've got the 2's cancel on both sides, and that dl1 dx is equal to x over L1. Taking the derivative of something squared, just bring the exponent down and lower it by 1. But if this is a function of x, you have to multiply by the derivative of it with respect to x as a chain rule. And we know that it does depend on x, so we have to do that step. On this side, a is a constant, so it's by. Derivative of x squared with respect to x is just 2x. What's that?
We're using the table of x.
Yes. All right, so we've got this. Now do the same thing here. When I take the derivative of the L2, I'm going to do the same thing. So I get, actually I'm just going to do it without writing anything. It's the 2